Hi, it's David with Oklahoma Ham Radio, the YouTube channel, and oklahomahamradio.com. Please like and subscribe. It will definitely help. Hey, I'm over 100 subscribers, so that's an accomplishment. I'm working on the antenna again, and I've changed it up just a little bit. I've tried multiple things on mounting the base. How do I attach things into the actual antenna? So this is a video about really the base and what I'm doing there. Stick around. Thanks. So one of the things with this antenna build that I struggled with was what to do at the base, how to connect things, all these elements at the base. Right now I've got 4 out of 5 connected. I'm going to show you what I did. This is marine bus bar. When I say marine, it's like aqua. And I tried or looked at doing a few other things with some 3D printed stuff. So here's one that I had 3D printed, had some posts sticking up where each one of these feeds would be, and a cable that would attach to the center post of the coax there. This one I 3D printed with the thought that I could, screw something like this in there, right? Screw it down and then solder onto the end post on the other side. Ultimately, I just went with this. It was simple, sometimes simplicity, and yeah, it just works. So also that's stainless steel. So there is a piece here that does cover up the top to somewhat weatherproof and protect it. So I'll leave that for right now, see how it holds up. I don't have the coil finished yet. Actually, I have it built, but I don't have it to where I'm comfortable with putting it on yet. So right now I've got 4 bands on here. They all seem to be working okay from the meter, that NanoVNA, and I'll figure out if I'm going to put that coil on here or not. If I do, I'll have to move this, which is my 20 meter element currently. Now what I'll do is have another one made this size and put it over here and through this hole, and tune it, and then use this 20 meter element for that coil, because it uses 20 meters off the top, a 20 meter element off the top of that coil. The other option is to go up to the 20 meter point at the top of the antenna and then across to a tree over here, or across to a tree over here, and do a inverted L for 40 meters. I'll see how it works. I'll see which is better, the coil or the inverted L. I do have a third option. I still have a lot of these poles, and I could go up higher, which I'm trying to avoid, and just make another vertical element for 40 meters, which would definitely give me 15 also, which would make this a 6-band antenna, homemade antenna, based on Callum's design. I am wearing his shirt. He's the one that came up with this design. I just modified it slightly to work for my environment. So thank you, Callum. I appreciate the hard work that you've put in to figure a bunch of this stuff out. And without people like you, people like me would have no clue where to begin on some of this stuff. So I appreciate you. There have been some questions about the ground radials and what about mowing and things like that. I'm going to show you real quick. I'm going to do an up close on the ground, just so that you can see what happens after about a week to 2 weeks. So there are ground radials running underneath all of this grass. If you can see one and you're worried about mowing over it, mean, I've covered a pretty sizable chunk of the yard here. And just to show you that there really are ground radials, I'll go to a spot that doesn't have much grass. Well, in fact, that's even grown over. See if I can find another place where some may be slightly exposed. Right here. So even this one, I'll hold it right there. Ground radials right there. You're not going to mow over it. If you've got your mower set that low, you're doing nothing but kicking up dirt anyway. So what I've got now is down here, I've moved the lightning arrestor. Move this out of the way. Move the lightning arrestor right here on the base of the antenna, and that gives me a little more firm or stable mount to that point. And then I'm attaching to this, I don't know, it's a marine, let's see, it says Tim Plateo Corporation. It's a marine bus bar. It's the closest I could get to what, you know, Callum's doing. Right now I've only really got 20 meter hooked up on that bus bar. So let me show you the results. Now I'm using a different tool, but I'm still using an iPad and connecting internally to NanoVNA, but I've got the second version of that now because I had some issues with my first version. But plus I wanted more points, right? So now I can get 1,024 points per sweep. So it's pretty cool. But on 20 meter, hopefully you can see this okay. On 20 meter, which goes from 14,070 to 14,350 in the US, that blue line is my SWR, which is all below 2, well below 2 to 1. That's about as low as I'm going to get it, and I use SSB, which is on the upper side of that band. So I've got it to where, you know, the CW range down there is a little higher SWR. SSB is really good, but it's really flat across the entire band. Also, let me move this over. There's the Smith chart, and I'll go ahead and add some points of reference so that I can see what those the SWRs are at those points. So I switched over to 17 meters just to see where I was at without really doing any adjustments. Over here, 0.1 and 0.2 are really the edge of the bands that I'm interested in. I've extended the range some to, you know, so I can see where the dip is. And right now it's down here between 17.868 and 17.917, which is a little low. So I'll cut a little bit off of the cable, see if I can't move it up here. But really I'm at 1.16 at 18.17 megahertz and 1.13 at 18.06 megahertz. Really, that's good, but I'm going to try to make it perfect since I'm building my own antenna. So we'll go shorten it up just a little bit. So here's what I'm starting out with on 12 meter, which is 4 to 1 SWR. So let's go see what I can do about that. I've been messing with the 12 meter element for quite some time. 12 meters is really a small band, so let me show you. Mark 1 and Mark 2 on this are the 12 meter band. And let's see, Mark 1 is at 2.86 SWR, 2.86 to 1, and Mark 2 is at 2.77. As you can see, even if I adjust it over, looks like increase just a little bit of length, I'm not going to get much out of it. So I think I'm done messing with the 12 meter element. We'll see if it adjusts differently as I add the 10 meter element and go from there. But that's where I'm at. So this is where I'm at on 10 meters. So Mark 5 right here, basically is SWR for 4 to 1. Actually, it's 3.78 to 1. Over here is the next closest point to 4 to 1. So if we look at those frequencies, one second. If we look at where I align those frequencies, it is 28.36 is the first mark, and 28.31 or 29.313. At this mark, I'm sitting well below. Over here, I'm sitting well below 2 to 1. It's probably more like 1.5 to 1, which corresponds up in this area, which is good on the Smith chart. So basically, I've got a very small frequency or bandwidth, really number of frequencies to work with this antenna. In fact, let's go see exactly where the sweet spot is. So I'm at 1.39 to 1 at 28.53. The phone bands are from 28.3 to 29.3, so I tried to align this as well as possible to be able to use the phone bands. In fact, let's switch this up just a little bit, change my sweep from 28.3 something on my screen right there, 28.3 to 29.3, and see what it comes back with. So this is 1,000 points that I'm scanning at, actually 1024. So it takes a little bit of time to scan. So let's go figure out where. Let's see, let's change this one, this point all the way back to the beginning of this chart. Let's take this one. Well, that's pretty much right at the sweet spot right now. So 28.5 looks like 28.52. And then let's take this one. Over here to where I hit 4 to 1 SWR roughly. Let's take the first one to where I hit 4 to 1 SWR also. Let's see, that's still at 5 to 1. So about right there. So really I can communicate between 28.36 and 29.08. So I've got a little bit of room. Nothing great on 10 meter. So let's see, I've got 10 meter, 12 meter. Let's see, 10, 12, 17, and 20. So there's 10 right now. I'm going to go ahead and record myself changing between these so that you know I'm not just going to different antennas or something. Let's see. So right here from the official guide from ARRL, 14 to 1435. 14 to 1435. 0.35. Let's let that go through an entire sweep of those frequencies. In fact, I'm going to go ahead and turn off these marks. So over here you can see I'm at a very low SWR across the entire 20 meter band. When you scan 1024 points, it takes a bit of time. It takes a minute. So I care more about the upper end of this band than I do the lower, because the upper end has, you know, calling frequencies, SSTV, not that I'm going to do much of that, some packets, some beacons, right? So anyway, that one looks good. So let's go to 17. 17 is 18.06 roughly to 18.17. Let's do 18.1 or 18.06 to 18.17. $18.06 to 18.17. Go ahead and leave it at some high resolution here. Scan that band. So there's my SWR down there at the bottom. 17's great across the entire band. Not that I care a whole lot about 17, but man, I may be hanging out there some. Over here you can see the scale. So I'm pretty low on 17. I really need to screen in this patio. Okay, so let's go to 12 is 24.89 to 24.99. This should be about 3 to 1, a little lower than 3 to 1, but it's the lowest I could get it on this band. So 12 is a very small band anyway. Flies are just enormously bad in Oklahoma right now. So I'm pretty, I'm as good as I can get across that band, 2.7 or so to 1, roughly. So that's, you know, I can do that with the ATU on a radio. So let's switch to 10 again. Sweep parameters. 10 meters is 28 to 29.7, and I already showed this, but 28 to 29.7. Let's go ahead and sweep that band. I think that's coming off the end of 12, and then it switches antennas or switches elements. So again, in the phone area, I can use the radio for most of it. pretty sharp dip there. And about right there, the ATU is going to quit working. So not horrible, definitely doable with the tuner, obviously. All right, so the software I'm using is different than what's been shown before across, you know, multiple channels. It's called VNA_QT. The reason I'm using it is I got a new VNA, and it is the second version, VNA 2, NanoVNA S-A-A-2. I'll show a little bit about that here in a second, but it does use different software. You can't use NanoVNA Saver with it, that I've figured out how to do. When you go to calibrate it, it says that 2 of your calibrations are the same. All right, thanks for watching, guys. Please remember to like and subscribe. I appreciate you. I'm over 100 subscribers now. If you know somebody who might like this content, point them this direction. Thanks, guys.